Hello friends, welcome once more to class online. My name is Dami, and in this edition we shall be looking at Waec Physics 2013 question number 11 to number 15. And in this edition we have questions on moments. Now if you have problem with that, that will be we have a question that will better help you understand it. I will take you further in understanding. And we have questions on simple pendulum oscillation and other aspects of physics that will interest you and that will teach you a lot of things. Now, don't forget that if you learn something from this video and you want to get more content from us that will better help you understand physics, click on the like button. We have a lot to share with you that will best help you analyze a lot of things. Now, let's get to number 11. This is a moments question. The diagram above illustrates a uniform meter rule which is balanced on a pivot by some masses. Calculate the value of M. Now this is saying, you can see these are all forces, right? Sorry, these are all distances from the middle point, right? This is 50, this is the middle point, because this rod is supposed to be 100 centimeters naturally. So the middle point of the pivot is 50 here, according to this drawing. So now here we know 40 here and 10 here. So that means the distance between this point and the pivot is just 10 centimeters. Then from here, what will be the distance from here to the pivot? So the first thing to do is to find what is the distance between M and the middle point here. And that is, since M in the drawing is 10 here, so that means from 10 to 50, it will be 40 centimeters in the middle of that. Because here is 50, the middle is 50 here. And if from here to here is 10, that means we have 40 left. And that is 40 centimeters here. Then here, if here is 4, and we have been told that here is 10 naturally. So from here to here is 10. So we have 40 centimeters here and 10 centimeters here. That is their distance, the distance of the masses of this mass and this mass to the middle. And that is the first thing to find. Now when you finish that, multiply the first mass. You know, moment formula says that what? Clockwise moment is equal to what? Anti-clockwise moment. So you have to multiply the mass, this mass, the moment of this one and the moment of this one. You have to equate them. That means this left hand side have to be equal to the right hand side, and that is what you have here. So the left hand side here will be equal to this side, and that means I'll be saying here is what? M times 40. That means this mass times its distance equals the second mass 100 times what? 10. And that's what I have here. So I will now find the mass M here. Very easy. So 40 times M is 40M equals 100 times 10 is 1000. Divided by 40. Divide both sides by 40. 1000 by 40 is 25 grams. And that is a simple answer to the simple question. Just find the distance between here to here to the middle and here to the middle, and then multiply this and the distance, this and distance, and equate them, then get your answer. And that's just the easy answer to the easy question. The period of a simple pendulum F is 5 seconds. What is the period of a simple pendulum Y, which has 500 vibrations? In the same time, it takes X to make 20 vibrations. Now, YS was making 20 vibrations. Now, normally we said from the beginning that there's that one oscillation or one vibration is 5 seconds. But 20 will now become what? 20 times 5, and that's 100 seconds. So this Y also use the same time. So that means this 100 seconds also applies towards Y. So the time for Y to complete its own is also 100 because they are sharing the same time. So for S, you know, we said the equation that one vibration or one oscillation according to this question is 5 seconds. But S made 20 of it. That's 20 times 5, and that's 100 seconds. It spent 100 seconds to make 20 vibrations. Now they say that the time is shared for X and Y. That means the same 100 seconds is also for Y. Okay, now, but Y made 50 vibrations. So what will now be the time? So you have to divide 100 by 50, and that becomes 2 seconds. And that is the simple answer to the simple question. It is just 2 seconds, and that is the answer. Now let's get to number 13. Alcohol of mass 21 grams and density 0.7 gram per centimeter cube is mixed with 10 grams of water. Determine the density of the mixture. Density of water equals 1.0 gram per centimeter cube. Now what you have here is just mass and density. Okay, and another mass, then you have to find the last density, right? Right. Now, first of all, you can't find, now there's a problem here. This alcohol, it has mass and density. And then there's water, mass, but there's no density. Okay, and you are not told to find the density of the water. You are told to find the density of the mixture. That means they've given you the density of water here. This is density of water. This is the mass of water. This is the mass of alcohol. So they have given you their masses and their densities. The density of alcohol and the density of water. You have to find the density of not alcohol and not water, but their mixture. So the first thing, notice one thing. Density is mass over volume, right? But you were not given their volume. So the first thing to do is to find the volumes. Volume of alcohol is mass over density. Turn the formula of density upside down. It will become density equals mass over volume. So volume is equal to mass over density. And that's mass is 21 over density is 0.7, and that will give me 30 centimeter cube. That is the volume of alcohol. Then volume of Then volume of water is now mass of water over density of water, and that will become 10 over 1, and that is actually 10 centimeter cube. Then you have found the volume of the two of them. Now, first of all, find the volume of the total of the mixture first. So the volume of the mixture is 30 plus 10, and that's 40 centimeter cube, right? You added the volume of water and alcohol, and that gave you 40 centimeter cube, right? Now, for you to be able to find the density of the mixture, you must also know that density is mass over volume, right? You have found the volume. Now you have to find the mass. So what's the mass of the mixture? Look at the mass of water and the mass of alcohol. And that is, the mass of alcohol is 21, the mass of water is 10, and that's 10 plus 21, and that's 31. So now the density of the mixture is now going to become the mass of the mixture over the volume of the mixture. What's the mass of the mixture? 31. And the volume is 40, and that will give you 0.775 gram per centimeter cube, and that is the density of the mixture. First, find the volume of the mixture by dividing the density and the mass and density of each of them. Get the volume, add up the volume, that's the volume of the mixture. Then find the mass of the mixture, which is the combination of the mass of the two of them, and that's 31. Then divide the mass by the volume, and you get the density of the mixture, and that's just it. And that is just it, full stop. Nothing more, nothing less. And that is just the answer. A is the correct answer, and I believe you can do it. Now, a device that converts mechanical energy into electrical energy is what? Do you know what that is? That change machine energy, mechanical. The word mechanical came from the word machine into electrical energy. It converts. Oh wow! This actually, it changes as you are moving the machine. It produces electricity. Do you know what it is? Now, the answer is it a dynamo, or electrical motor, or inductor coil, or transformer? The answer is very, very simple. And the answer is actually a dynamo. Do you know why? Now, when you see the word mechanical is machine, like if you are, the dynamos are mostly found, they are sometimes found, or most times, around bicycles. Bicycles that have no light. There are some bicycles that they don't use battery light. They use dynamo lights. And how does it work? When you are rolling the tire, when you are running with the bicycle, you are creating mechanical energy. There is a tool on that bicycle that changes that energy in the tire that is rolling into electricity, and it uses that energy to light up the bulb in the bicycle. That means the bulb of the bicycle is working because of the rolling of the pedal, which is made by your leg on the bicycle. So that means as you are pedaling the bicycle or cycling, you are creating energy that is used to power your bulb, the bulb in the bicycle. And I've even seen a motorcycle that uses the same principle. The motorcycle does not use anything to power its light. It uses the light only stays on when the motorcycle is moving. That means when the motorcycle stops, it can't be lighted. So and there are motorcycles like that also. So when the man is running, there's light, but when the man stops, the light goes off, and that's the way it works. So it is done by the changing of mechanical energy in the rolling tire when the tire is rolling into electrical energy that shows light, and the electrical energy is the one that powers the bulb in the amp on the machine, and that lamp produces light, and that's the way light comes. So it changes mechanical energy into electrical energy. Another example is your generator. You know, when you want to power your gen, you have to pull. When you pull something roll, that coil roll, there's this coil that roll, when it rolls, that's mechanical energy. You are setting mechanical energy into motion so that it will produce electrical energy. So another example of mechanical energy changed to electrical energy is your generator set. But when we talk about electrical energy changing to mechanical energy, you'll be talking about things like motor, electric motor, rotor, things like rotor. Like if you want to on your fan, there are rotors in the fan. If you want to on the fan, you will put on the light, you will switch it on the switch. When the fan starts to roll, then you will see that electrical energy will get to the fan and will roll to the coil, and the fan will start to roll. So it is electrical energy producing mechanical energy. That's for a rotor, or for a motor. But for a generator set or a dynamo, it is mechanical producing electrical. It is just opposite. Mechanical producing electrical is generator or dynamo, while electrical producing mechanical is electric motor. And that is the answer for number 14. So the answer to that question is not an electric motor, it is actually a dynamo. And that is the answer. Electric motor converts electrical to mechanical. Don't mix it up. While dynamo converts mechanical in a bicycle like I have here into electrical in the lamp on the bicycle. And that is the answer. It is dynamo. The SI unit for power is what? Now, in what unit do we calculate power? Is it Newton, Pascal, Watt, or Joule? Joule is for energy. Watt is for power. Pascal is also for pressure. And Newton is for force. So the simple answer to that question is that power is measured in watts. The SI unit for power is watt, and that's power is work over time. Work is joule, and time is seconds, and that's it. The answer is just watt, and that is the simple answer to that question. And that brings us to the end of this video. Don't forget that if you learned something from this video, I want to get more content that will better help you understand. Click on like button. We have a lot to share with you that will better help you understand things. Once you see it, guys, take care of yourself and bye for now.